For the equation f of xy equals negative 1/9 x to the third plus xy plus 1/2 y squared, we first need to find the f of x and f of y. For f of x, we do 1/9 times 3, and it equals negative 1/3 x squared. And then we get y minus x squared over 3. We get the y from multiplying the x times 1, getting y. For f of y, we get x plus y. We get this by taking away the x's, and we get x plus y, or x times y, and we take away that y, we get x plus, and we do 1/2 times 2 is just going to equal 1, so it's going to be y. For the critical points, I got 0, 0, and negative 3, 0. I did this by taking y minus x squared divided by 3 equal to 0, and then subtracting the y to get y equals x squared over 3. Then using the f of y equation, x plus y equals 0, I found to get y equals negative x. Negative x equals x squared, and you divide that by 3. Negative x minus x squared over 3 equals 0, so we're going to set that to 0. Get negative 3x minus x squared, set that to 0, and then we're going to distribute the x to the 3 and the x inside the parentheses, getting x to be 0 and 3. Then we use the y minus x squared over 3 equation, set that to equal to 0, multiply each side by 3, getting 3y equals x squared. Now to get x alone, we take the square root, so we get the square root of 3y equals x. Then we're going to plug in the square root of 3y into the x plus y equation and set it to 0. So the square root of 3y plus y equals 0. Then we do 3y equals y squared. 3y minus y squared equals to 0, and we get y equals 0, thus getting our critical points to be 0, 0, and negative 3, 0. Now the partial and second derivatives would be f of x equals negative 2x over 3. For f of xy, we got 1, f of yy equals 1, and f of yx equals 1. Now we set this up and we cross multiply them to get negative 2x over 3 times 1 minus 1 times 1. Now as you can see here, I set it up to be the critical points, the determinant, and the f of xx, and the result as a table. Now we do the 0, 0 as negative 2, and we plug in the 0 for the x, so negative 2 times 0 divided by 3 times 1 minus 1 times 1, and we get a negative number. We get negative 1. And the determinant rule states that if d of a of b is less than 0, we have a saddle point. Now, for the other equation, we put in negative 2 times negative 3, and we put negative 3 in for the x value, divided by 3 times 1 minus 1 times 1, and we get a positive 1. Now, the determinant test says if d of ab is greater than 0, then we plug it in f of xx. Now, f of xx equals negative 2, and we plug in that negative 3 again to get negative 2 times negative 3 divided by 3, and we get 2. Now 2 is greater than 0, thus we get a relative min. So we don't have any maxes, so there's going to be no relative maxes. There's going to be a relative min at negative 3, 0, and then there's going to be a saddle point at 0, 0.